Setting out of grade lines. Hello everyone. Grades are everywhere in our daily life. Let's take a look at some pictures. Yes, in the construction process of these projects, it is necessary to establish the design grade lines on the ground to guide the project construction. Today, I will talk about how to set out a known grade line using a level gauge through the horizontal sightline method. First, understand the concept of grade line. In the event of the setting out of a known grade line, the level gauge survey method is used to mark the design elevation of a certain point on the grade line on the ground based on the design grade and the design elevation of the grade endpoint. Instruments used. Theodolite, compass, and total station can be used to complete the setting out. There are two methods of setting out: horizontal sightline method and oblique sightline method. The horizontal sightline method is suitable for setting out grade lines with relatively small surface gradient, while the oblique sightline method is suitable for setting out grade lines with relatively large surface gradient. After understanding the concept of setting out the known grade lines, how can we use a level gauge to set out the known grade lines through the horizontal sightline method? We will explain this below. As shown in the figure, on a certain construction site, there is a known benchmark point 5 nearby, with an elevation of h water 5. A and B are the two endpoints of the grade line, with a horizontal distance of d. The design elevation of point A is Sh. In order to facilitate construction, a wooden peg, grade peg, is to be driven into the ground at a regular interval d along the AB direction, and a grade line with a design gradient I is to be marked on the pegs. Next, we will explain the survey steps as shown above. Step 1. Along the AB direction, mark out the middle points 1, 2, 3, n at a specified interval d. We will mark out 3 points here. Step 2. Place the level gauge in an appropriate position between point A and B, and sight back to benchmark point 5. Read the back sight reading A, and then calculate the sight line height h. High equals water 5 plus A. Step 3. Calculate the design elevation h of each peg point based on the design gradient I and the design elevation of the starting point of grade line, design equals starting plus ID. The elevation of the first point, h1 equals HA plus ID. Step 4. Combine the instrument's sightline height high and the design elevations of each point design to calculate the expected reading expected on the leveling rod of each grade peg, expected equals high design. Step 5. Place a leveling rod at each grade peg and move it up and down. When the leveling rod is on the expected forward sight reading, the corresponding position of the zero end on the level gauge is the design elevation mark for that point. As shown at point A, place the level gauge on the side of peg A and move the leveling rod up and down. The reading at which the level gauge aligns with the rod is BA. Mark with a pen at the bottom of rod, thus obtaining the point with a gradient I and design elevation HA. Step 6. Verification. After setting out the grade line on the grade pegs, check if the marked points are accurate. Reinstall the instrument in an appropriate position between A and B. and back sight point 5. Read the back sight reading A to obtain the sightline height high equals h5 plus A. Calculate the expected reading. Expected. Draw a line on the grade peg and place a leveling rod. Measure the actual reading of each point, and calculate the error using the expected readings during setting out process, the actual readings during verification process. For example, at point A, place the leveling rod at the marked position on the grade peg. Use the level gauge to read the actual reading B on the leveling rod. Then calculate the error, equals BABA. When less than or equal to plus or minus 5 mm, each point meets the survey requirements. I hope that through this lecture, you can master the horizontal sightline method for setting out a known grade line using a level gauge. After class, you may further improve the understanding of specific operation process of setting out a known grade line through practical experiments, and complete the post-class knowledge expansion tasks.